Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. For this video, I'm going to teach you about the line integrals. Okay, so line integrals is also known as curve integrals. Okay, what is curve integral or line integral? Line integral or curve integral is the integral of the function that is evaluated along the curve C, which means that you have a curve C and we want to find the integral function along the curve C. Okay, it can be evaluated in a scalar field. For instance, obtaining the results in the mass of a wire from density, or in a vector field. So the difference between the scalar field and the vector field. Okay, so for vector field, which give you the amount of work done on a particle that move along the curve C. Okay, let us see the example. So let's say this figure show you the parametric representation of 2D space. Okay, so you have x and y axis. So this is in two-dimensional space, and you have a curve C. Okay, you have a curve C. So this is your curve C. Okay, your curve C called the path of integration, where from point A, from this point to from point A, this point to point B, that point. Suppose the parametric representation of the curve with parameter t. So what I want you to know here is, let's say you want to move a particle from this point to this point. Okay, let's say the particle is like this. Okay, so you want to find what is the total work done. What is the total work done? Okay, to move a particle from this point to this point. So in order to find the total work done in calculus vector, we need to find the curve integral or line integral. What is the difference between the work done that we have studied or we have learned during our secondary school, and now what is the difference? The difference is, previously in physics, okay, we want to find the work done over a flat surface. For example, you want to move this object, okay, from this position to this position. So this is the distance. Okay, so you want to pull or push this object from this point A to this point B. Okay, and then you want to find what is the total work done. That is for flat surface. Okay, so now the difference is you have to deal with not a flat surface. Apa jadi mulut saya ni? Okay, not a flat surface. So that is the difference. Okay, in order to find the total work done to move a particle from point A to point B, okay, in a vector field, we call it as we want to find the line integral. Alright? Alright, class. The line integral, okay, the line integral is defined. This is the definition of the line integral, okay. And in mathematical form, in my class, I will always, and this is my favorite formula to find the line integral instead of this one, just the same thing, but I will always use this formula. Okay, what does it mean? You want to find the total work done along the curve, okay, along the curve C. Then you find the force field. Okay, this one is the vector field F. Okay, dot with your dr. Your dr, okay, your r is the position vector. But now, when you have dr, means that you take the first derivative of the position vector. Okay, so dr means that r prime t dt. This formula can be adjusted as C, okay, F dot r prime t dt. Oh, sorry, not adjusted. This r prime t is actually comes from rt. Okay, we want to know what is rt. RT is the parametric equation that we need to find. Okay, RT is given by X in term of T. Your Y is not Y, but your Y in term of T. And your Z is not Z, but your Z is in term of T. Okay, so R is the position vector which define the form of xt of I plus yt of j plus zt of k, and then you find the first derivative of R, then you plug in into the formula of line integral. Alright, so what are the steps of solution in order to get, what is this? This is step 2 and this is step 3. Okay, so what are the steps of solutions in order to solve for the line integral? The first thing is you need to know how to sketch the curve from the given information. Okay, let's say you are dealing with the line integral where the type of your integral is just a line segment. Line segment is just like a straight line graph. Okay, from this point to this point. Okay, let's say the type of your curve is just like a quadratic equation. Previously, we know this one is quadratic equation. Okay, normally in vector calculus we call it as a parabolic equation. Okay, so from this point to this point, so probably we have here is the direction. Okay, from this point to this point. So this is the type of curve where you are dealing with parabolic, or probably your type of curve is a circle. So what is the equation of a circle? X squared plus y squared equals to r squared. You need to watch again all the videos regarding to polar coordinates. 3 videos regarding to polar coordinates I already posted on YouTube. So please check on how you can sketch the type of curve, how to determine the limits and so on. Okay, so that is the first step. You need to sketch the curve based on the information given. The second step is you need to identify the category of curve, okay, and find its parametric equation. What is the parametric equation? Your RT. Okay, your parametric equation is your RT, which is given in the form of xt, yt, and zt. You need to find out what is your RT. Okay, and then you finally you solve the problem, okay, by using the definition of line integral. So where is the definition? So the definition is here. Okay, f dot r prime t dt. First of all, find what is your RT. Okay, and then differentiate, and then dot with your f, and then determine the limit so that you can solve for the problem. So what is next? Okay, so this is really important thing where just now I mentioned you need to find out what is your parametric equation, right? Which is given by x of t, y of t, and z of t. Okay, in order to fulfill this formula, this equation, what you need to do is you need to identify what is the type of a curve. Okay, let's say your type of curve is a circle. So in order to write down your parametric equation, your x here is replaced by r cos t. So you substitute here is r cos t, comma. So y, your y is, oh, my y is r sin t. Your r is your radius. Okay, so circle, we don't have z. So z is 0 lah. Okay, because you have circle is the form of 2 dimension only. If you have 3 dimensional, it will becomes a sphere. Okay, so for circle you don't have z here. Alright, so the same goes to ellipse. Okay, you try to rearrange your equation. If you get x squared over a squared plus y squared over b squared equals to 1, so that in order to get the parametric equation, what you need to do is just put x of t y of t, z of t, and then determine, oh, I have ellipse. When I have ellipse, so this is my x, put it here. This is my y. And the same goes to ellipse. Ellipse in two-dimensional only. So you don't have z, your z is 0. So what about line segment? Okay, so for line segment, line segment is just like you have a straight line point from point A to point B, for example. Okay, you want to move a particle from this point to that point along this curve C from point A to point B. Okay, this is the type of line segment. Okay, so for line segment, what you need to do is your RT is automatically using this formula 1 minus T. Okay, and then find your x0, y0, z0. What is x0, y0, z0? X0, y0, and z0 comes from your initial point, the starting point, and substitute here. Okay, plus t. Okay, this one, and plus t, and then multiply by x1, y1, z1. So what is this? This is the destination point, and substitute here. And then you try to modify the equation until you get your RT. And do not forget to get the points from A to B. So what is the point of A to B? And normally from if you have a line segment, the point T here is from 0 to 1. T0 to T1, which is from 0 to 1. So we can try to verify this statement later. Okay, so that is the introduction of line integral. So after this, we try to discuss some exercises or some examples for the next video. Thank you, class.